solar mini-grids have turned from small pilots to an electrification wave. We were there when mini-grid regulation was established. When financial transactions were closed, we saw new technology thrive and companies fail. This is where we tell the stories. This is where we discuss the future. The mini-grid business, powered by Insys.
Hello, this is Nico. Welcome to our episode about DC mesh grids with my guests Afnan Hannan from OKRA Solar and Felix Boldt from Solarworx. Afi is the founder and CEO at the mesh grid equipment manufacturer OKRA Solar. OKRA aims at combining the flexibility of solar home systems with the reliability of mini-grids, using their mesh grid technology. With the OKRA Solar system, power is distributed using extra low DC voltage, while each customer has access to an inverter supplying AC power to her or his appliances. Felix, who previously worked in Mobisol, is one of the founders and CEO at Solarworx. Solarworx is a manufacturer of modular off-grid solutions with a focus on solar home systems and DC mesh grids. Solarworx mesh grids share power between larger solar systems over low-voltage DC distribution lines, with the majority of the customers' connections outputting DC, with AC inverters output as complementary add-on. Felix, what is a mesh grid?
Yeah, hi everyone. Thanks very much for having us in the first place. So just straight to the first question. So a mesh grid is a decentralized DC microgrid. It's still an interconnection of systems similar to an AC mini-grid, but everything runs on DC, as the name indicates. And it's meshed because it's decentralized. So you have multiple solar systems across a community. And not everyone necessarily has to have a solar system, but in our case, usually 10% or so of the connections within a village have a solar system. And that aggregated power of those solar systems is shared across the community. So let's say 90% of the users just have a mesh grid box and 10% actually consuming energy from the solar systems that are feeding in the power into the grid. There's a couple of reasons why we're doing DC versus AC, but the main driver here is the cost, because DC technology, it's safe to touch, and therefore there's a lot of less safety hazards involved in that technology, and therefore we can drop the cost of it and make it an easier entry point for rural off-grid communities across Africa mostly.
Yeah, safe to touch as long as the voltage stays below a certain level, right? And that's what you're basically doing.
Exactly, yeah.
But that also increases the current, right? To transfer a decent amount of power at a low voltage, you need a relatively high current. And that causes losses, doesn't it?
Well, it does, but the consumption on DC systems usually is less because we're working with energy efficient appliances. As a solar home system company that we are as well, we are also sourcing fridges and freezers and TVs. And the consumption of a DC freezer in our case would be only 50 watts roundabout there. So the peak load capacity of those DC appliances is just significantly lower, and therefore we can tolerate higher degrees of losses.
Yeah, and there's probably another advantage. Most of our listeners are, of course, familiar with AC mini-grids, where you have a central generation station somewhere. And then from there, the electricity is distributed to all the customers over a relatively long distance, up to 1.3, 1.5 kilometers over low voltage lines. Now in DC and the mesh grids, you basically generate in a decentralized manner within the community. So the distance from the production of electricity to the consumer is not that long. Therefore, it may also be reasonable to accept the slightly higher losses due to the low voltage, but save a lot of costs, save a lot of CAPEX after all, right? Thanks to the lower installation cost and the lower material cost. Afi, do you want to add to that?
Yep, thanks, Nico. So let me try and help imagine this scenario. So let's imagine there's two identical grids and they both have 500 households and they're 50 kilowatt grids. Let's start with the AC mini grid scenario. So in the AC mini grid, you've got your centralized powerhouse. So let's say 50 kilowatts needs to go down the LV line. Assuming it's three phase, you can estimate a line voltage at roughly 500 volts. then at 50 kilowatts, you have 100 amps going over the line. So 100 amps, that's a lot of current and requires really thick cables, usually 50 mils squared or larger. In the same situation with a mesh grid, so 500 households, 50 kilowatts, let's say you're using 450 watt panels on rooftops, so that's roughly 110 connections with PV on the rooftop. In this situation, you've only got, let's say at max, 450 watts sharing from one system to the next. In the mesh grid, you use 50 volts DC distribution, so with even a much lower distribution voltage, you've got 450 watts over 50 volts. So that's 9 amps being shared over the distribution line compared to the 100 amps in the AC minigrid example. So that's less than 1/10 of the current being shared. And remember, power loss is proportional to I squared R. So if everything was the same, cables, etc., you would actually have 100 times less power loss over the line in the mesh grid. So yeah, that's kind of the advantage of the mesh grid. You can use much thinner cables, and we recommend using about 2.5 square mil copper or 6 mil aluminium, and you'd then have comparable power loss to the AC minigrid. So yeah, basically you can reduce the cost of distribution quite substantially in the mesh grid.
I think there's, maybe if I can jump in also, there's benefits in terms of mesh grid's operational cost, because energy theft is a major concern for utilities in Africa and also for mini-grid companies, I can imagine. And if I'm not mistaken, it can yield up to 30% of the entire energy generated in utility grids and AC mini-grids being stolen, after some time of installation, of course. I wouldn't say that's the first day, but it's going to develop that way. So with a mesh grid, for being a DC grid, the power line is pretty useless for the end customer. So they cannot just bridge the meter. If they do that, they're going to fry all their DC low voltage appliances, because they're taking that 60, 70 volt DC, jump that over and just destroy everything they have there. They tried that once, but never tried again. So there's not really a high degree risk of theft. And I think that's a major part here. And again, the security aspect is also very important, because if you can inclusively involve the community in the installation initially, because it's safe to touch, then that drops the cost of installation also dramatically.
Yeah. We are going into direction where we're discussing DC mesh grids versus AC mini grids. Whereas I see that there is a lot of complementarity even between those two, where AC mini grids, for example, could be established where there is demand for, tens of kilowatts of power for small industrial production or large workshops or these kind of things, where most likely AC three-phase power supply is well suited. And then there may be areas where there are more residential customers, where there are markets, where there are shops, where there are maybe hairdressers and these kind of small businesses, where DC systems like mesh grids may be very well suited. So why not operating two systems under one management?
Yeah, for sure. So I could jump in there. I might do a bit of a segue and then come back. On the segue, it's basically about DC mesh grids. So I think the name can in many cases be misleading, because the distribution is in DC for the reasons mentioned: safety, power theft, reduced cost. But in our mesh grids that OKRA provides, every single output is configured with AC power output, so that households can use the appliances that they're used to purchasing at the market. And so not all mesh grids are the same. I think the Solarworx mesh grids are slightly different to the OKRA mesh grids, and we also have slightly different philosophies on how to build it. So I think that's maybe something interesting we can touch on in a bit. But I guess for the OKRA side of things, I heard recently somebody say that mesh grids are the middle child of mini grids and solar home systems. And so I think that's actually a good way to look at it, that basically, you need to make sure that all of your kids are doing a good job and are serving the family appropriately. And I think where mini grids really thrive is dense areas. We're talking, thousands of households or more than that. Households are close to each other. There's big productive loads. And it obviously makes sense because you're not using much distribution and you're getting the benefit of high power and that shared kind of asset whenever an individual user needs some energy, they can get it and they can get it reliably. That's the benefit of the mini grid. And then on the other side, you've got solar home systems. If there's an isolated house in the hardest to reach part of the world, a solar home system can still connect that household. And so mesh grids really fit in the middle. We're trying to take the benefits of both. We're trying to be reliable. We're trying to meet a varying load. And we're also trying to get clusters of households or communities that are more sparsely populated, which actually make up a massive part of the addressable market. So I think if we're to use a general rule, I'd say that if there's less than 15 or 10 meters between households and there's like 1,000 households or more, a mini grid makes a lot of sense. And if we're looking at, going from 10 to 15 meters all the way up to 75 meters of distance between households, mesh grids make a lot of sense. And then you're looking at SHS making sense for everything that's isolated. And I guess a final note, maybe Felix has some input here as well, but SHS is actually becoming more and more competitive because as panels come down in price, as batteries come down in price, and distribution cost isn't coming down in price, you can start making bigger SHS. Still not going to get that benefit of like the variation of load and the shared asset base. But yeah, SHS, I think it is very exciting to be thinking about the future there too.
Yeah, and as we are talking about a collaboration between companies working on the different technologies, I would like to refer to a podcast episode that we recorded a few months ago with the title The Mini Grid and Solar Home System Multi-Technology Approach, a way towards more finance for the sector, with Lynn Wezonga and Gillian Huart. Lynn from Cross Boundary Access and Gillian from NG Energy Access. And in that episode, we already discussed how the different technologies could potentially be used in a harmonized approach by one company. And then there are so many synergies by having all the different customers covered and supplied with electricity, all the customers that belong to one village, having them all covered and basically doing that all through one team that knows all three technologies. Is that the way that you're also working in Africa?
Well, for us, definitely. I mean, for we are being a solar home system company and a mesh grid company, and at the same time an EPC company where you could say we're also serving the upper system segment in the higher kilowatt range, like 40, 50 kilowatts or so, right? Not exactly an AC mini grid, but definitely larger than what any private household in Africa would ever consume. So yeah, I totally agree with this multi-tier approach, and also the explanation of Afi, I think, really hits the nail on the head. Is basically saying mesh grids are the middle child between SHS and AC mini grids. I totally echo that statement. For us, though, I mean, when I'm saying we are doing it, I mean actually our developers are doing it. But I think it's a convincing job to do because either the developer is a mini grid company or it's a solar home system company. And they operate quite different. So it's a totally different child to sell an SHS versus having an internet-connected system and running it in a community from a regulatory standpoint, as well as from a community standpoint. The municipality has to be convinced, exclusivity agreements have to be signed. It's completely different than just talking to just one end customer, right?
Yeah. Now, talking about the three technologies, solar home system, mesh grids, and AC mini grids, the boundaries between those are still existing. You could not connect an existing solar home system easily into a mesh grid unless you follow, for example, the approach that is being used in Bangladesh, where you have similar types and characteristics of solar home systems that then could be upgraded to a mesh grid. But your companies are not doing that. Am I correct?
Maybe I can make a start, and if you can add to that. Our systems are very modular, so there's a sliding mechanism in our mesh grid where you can slide in battery extension boxes and solar home systems of our type. So there's a very cableless, seamless integration possible. But in general, we have designed our mesh grid systems to be taking any 12 volt or 24 volt standalone system that might be a solar home system and incorporate that in the grid. So you can even have customers that already have been paying off their standalone system for a long time. They've bought it in any random hardware shop in town and they installed it themselves. And if the developer wants to, they can basically integrate that existing fleet of SHS that they find in the village and integrate that into the mesh grid. Of course, it goes without saying that you wouldn't want to take a Pico system that has a 10 watt hour battery capacity and pump that into a grid where it's like hundreds of watts of power, right? It must be within proportion. But I would say if the SHS has an installed capacity of from above 200 watt hours or so, you may consider integrating that unit into the mesh grid.
Yeah, but that means that the small standalone system does not necessarily need to be from Solarworx to be integrated into your systems.
No, not at all. And in fact, actually, if we're building our mesh grids from scratch, we would not even use our own solar home systems. We would just source off-the-shelf lead carbon batteries, Canadian solar panels, off-the-shelf charge controllers, all this kind of things. You can really use anything. That's the great flexibility. So I don't think if you're a developer, you want to be dependent on just one manufacturer only. You want to have that flexibility. As an EPC company, we also like choosing between GoodWe and Huawei inverters or whatever is on the market, whatever is currently most available and most cost effective to us.
Yeah, nice approach. Afi, how are you handling this?
Yeah, so I think echoing similar to Felix, we want to ensure that any assets can be reutilized. And it's as simple as literally taking a panel off a roof and putting it into the input of our charge control device, the OKRA pod. So it's very easy to do. The challenge is actually primarily in the business model side of things. So people who already have assets, they own those assets, and then they're going to move, if they want to integrate that asset into the system, to the energy as a service model, where they're going to be purchasing energy from the developer who owns the assets. So ultimately, it just comes down to, does the developer have an agreement with this household to repurpose their assets, put it into the mesh grid, and then sell that household energy again, which I don't think is not achievable. However, so far, because there's such small capacity deployed in most of the communities that are being served, like the Pico Solar, which Felix was mentioning, there really hasn't been the need for this. But I can really see it in the future as the solar home systems start getting cheaper, more and more demand for this kind of thing popping up.
We can speak for like an anecdote from Zambia for where we installed a system like that, where we initially incorporated existing solar home systems. From a technical perspective, it has been working greatly. However, it becomes a social and maybe also customer education issue at some points, where you need to prove to the customer that you're not actually excessively taking energy out of their batteries. You're actually stabilizing their own batteries and therefore increasing battery lifetime, because you're not deep cycling their batteries as much as they would have been if they were still standalone. So we had cases where we had integrated, I think, 5 or so existing solar home systems that we found in the village into the mesh grid. And out of those 5, 2 wanted to be disconnected at some point, to be honest, because they thought that we would deplete their batteries. In fact, the contrary was there. I was trying to show them the evidence of the data, but it comes down to customer education and mutual understanding. So therefore, I would say that in the majority of the cases, the solar systems that power the mesh grid are owned by the developer that deploys the mesh grid.
Okay, let's talk about business models in more detail later. I have one more question. Like, we now talked about the transition from standalone systems, solar home systems, into mesh grids. Now, is there a similar transition from mesh grids to AC mini grids, or from AC mini grids to mesh grid? Could I, for example, install an AC mini grid, and on the edge of that AC distribution network, I say, okay, now from here, I extend further with a DC mesh grid?
Yeah. Taking a step back to summarize that first bit, the benefit of the mesh grid is that in sparse areas, we can reduce the cost per connection substantially by reducing the distribution cost. And we can provide DC output or AC output as well, which is how we provide the energy service. So really, the end consumer is getting the same thing that they would get from accessing energy from a mini grid. Where are the limitations? So with OKRA right now, we have 1.2 kilowatt AC output limitation from the standard box, and then you can scale that up to 3.6 by going parallel. But beyond 3.6...
Both single phase, right?
Yeah, single phase AC. And then after that, you've basically got a limitation with the OKRA pod where it's not making sense to add so much power electronics just to get higher power. But 99.9% of all the energy use cases in last mile communities is covered by 3.6. But if you look at the higher consumption than 3.6, let's say you got a 10, 20 kilowatt mill, this mill is going to generate a lot of income for the community, which is great. And it's also going to generate a lot of income for the energy developer, which they care about. So our products aren't really scaling up to that point. And I think that's where there's a really good fit for a centralized AC mini grid to power that productive hub. And that productive hub can be connected with an AC to DC converter into the mesh grid. So the excess power from the mini grid is actually supplied into the mesh grid, which is lower cost distribution networks supplying energy to all the households. That's actually something that we're working on designing with a couple of our developers right now. We've got the prototypes out and getting excited for a field deployment.
Sounds good. So now what is the difference between the OKRA solar technology and the Solarworx technology?
I think there's a philosophical difference in terms of if every system should be equipped with an AC inverter or not. So we believe in that, the main reason why we do mesh grids over AC mini grids is really the cost, and therefore adding an inverter to every existing mesh grid connection would be adding too much to the cost. So the majority of our systems within the mini grids or our mesh grids don't have an inverter. Especially the inverter is not inbuilt. Inverters can generally be connected, but it's an external inverter, usually working with Victron, and that's totally fine for our purposes. For the devices that have a significantly higher demand, we are quite open-end. So we have no limitation in terms of how many kilowatts can be used. Again, as we're working with Victron, we have developed what we call a Victron dongle, where the Victron is controlled similar to the mesh grid power output, but we're just controlling the AC output on the end of the inverter. And therefore, we can directly plug it onto the battery side. And that system then is literally independent of the capacity of the mesh grid box, even though from the customer experience, for them, it looks like as if they're paying the same thing. So paying for AC output of the inverter or paying for the mesh grid is all the same. So that's one difference, I think, between us and OKRA. Another difference is that, again, for trying to drop the cost per connection as low as possible, we do not integrate charge controller into every of our mesh grid box. In fact, we're working with external off-the-shelf charge controllers because for us, usually only every 10th connection or so gets a solar system. So we only have the charge controller in the house where that PV capacity is needed and where the charge controller ultimately is needed. But in 90% of the cases where the charge controller that would be inbuilt would be idle and being unused, we just don't put it into the mesh grid box in the first place. I think those are the major differences in terms of feed-in capacity. On a DC side from or into the grid, we are between 250 watts and 500 watts that can be either extracted from the battery and pushed into the grid or taken from the grid and made available to the customer on the low side, as we call it, which is usually 12-volt power output.
I see. Mm-hmm. Listening to you, Felix, would you agree to the following summary that the Solarworx system is probably more modular and customized, and that in the OKRA solar system you try to drive down costs through having a large number, like economies of scale in equal parts. Is that a correct summary?
Well,
Afi and Felix?
Well, I think that both systems are still very flexible in components that can be used. I would disagree to this part of the explanation. Both of us, we are aiming for economies of scale. I think the reason why some of the differences are there are because of the markets that OKRA and us are working in. We are operating mesh grids at the moment in Cameroon and Zambia. We don't really have a need for that many inverters, while OKRA might have that need because operating to a large extent in Nigeria. But I think Afi can speak more to that.
I think the major difference, it all stems from philosophically what Felix mentioned, that he doesn't believe as of now that every house needs to have AC power output, whereas we believe that every house should be equipped with AC output because that's what they're used to using, and that's going to enable them to use more appliances, which is going to boost income and then sustainability of the projects. I think it really stems from that, and that actually feeds into a couple of design decisions. And so where Felix said they have one box per 10 households to really get the costs down low as much as possible makes a lot of sense, but that's a trade-off. We typically have one box per every 4 to 6 households. And that means...
Sorry, when I jump in there, but when you say box, you mean the system with a solar system connected,
like a hub or a prosumer.
You have the box. The boxes are in every household, just to clarify.
Yeah.
But you have one solar system every 4 or something.
Yeah. So imagine like where the battery and the PV is installed. In the Solarworx system, it's roughly, let's say, 1 per every 10, just for illustrative purposes. And with the OKRA mesh grid, it's 1 for every 4 to 6 households. And so obviously there's a trade-off there. So Solarworx is trying to push down on the costs, and then what we're trying to do, while always pushing down on costs, but to make sure that there's slightly shorter distances, which means you can get more power availability, which means you can run inverters without tripping the system, which means you get AC power output. So those are some of the kind of trade-offs between the two techs.
Well, there's another reason apart from cost that I believe that it makes sense, right, to provide a lot of capacity to an end customer, obviously. And that's why I think in certain degrees, AC mini-grids from the total power output can, under certain circumstances, be superior to a mesh grid. Mm-hmm. But in many of the villages, the energy demand is simply not that high. So you can achieve the same quality of service with just a DC connection. And no one, like even in our mesh grids, prevents the end customer from buying an inverter and then powering those less efficient AC appliances and ultimately paying more on the electricity bill, plus the upfront cost of the CAPEX of the inverter, right? There's pros and cons, but I think if I'm categorically equipping an mesh grid connection with an inverter, then I might just use a bunch of microinverters in every household and just run them all in parallel mode. I mean, I know that many of the microinverters as they are on the market don't provide the same degree of regulation that your mesh grid and our mesh grid has in terms of droop control regulation, all that.
Yeah, but then you've got like a 230 volt distribution line, so it's no longer safe, and it's adhering to safe extra low voltage, which is a bunch of the stuff that you're talking about at the start, right?
Exactly. So the argument of safety indeed is gone. You'd have to introduce a lot more safety features, MCBs, residual current arresters, and all that kind of stuff. I agree. But at the same time, you still have that big benefit of decentralization. So you can still have that argument of dropping costs because you can cluster systems as opposed to we have a centralized location. So I think there would be very good reasons to look into and comparing costs and like, would it make sense to design a sort of like microinverter as we know it from the PV panels, like, those balcony systems and microinverters that you can find always connecting those 2 panels within a larger system. You can retrofit or use them and then make something like a mesh grid, but on an AC basis. But as I said, like I really believe in that DC because again, it drops cost, it's decentralized with all the benefits given. But at the moment I'm moving AC on every household, I really would consider personally if I retrofit my technology to be based on AC also on the distribution line.
Yeah, and this AC connection of different nodes, that is what we are going to test in a pilot system in Uganda pretty soon. That is where at the, so to say, end of the line, after 1.2, 1.3 kilometers, low voltage line, we are setting up another node with another AC inverter and PV panel and a battery to support the voltage at that node, at that point, and then extend the AC network by another 500, 600 meters to be able to then cover a total length of 1.8 kilometers just instead of 1.2. This is basically a mesh AC grid, so to say. But it's in a early pilot stage, and we will know more by Q2 next year.
Do you see that the developer would be better off designing with DC or AC because you want to grow the load growth and you think this is what's going to unlock that?
Good question, indeed. We haven't done the calculation at that point. As you know, we're coming from the AC world, and the idea was, well, usually you install medium voltage networks on top of your low voltage network, which is extremely expensive to extend your AC network. And then you have transformers and everything. And the idea was maybe we can bring down cost by having a decentralized generation within that AC network and support the voltage at a certain point. But of course, deploying that point in the network to install an AC to DC converter and then from there go on with a 60 volt DC distribution would probably also make a lot of sense and may even be more efficient. As beyond these 1.3 kilometers, you would anyway not connect any heavy loads to the AC network anymore. Mm-hmm. And therefore a DC network could do the job as well.
And then our philosophy would be that all of those customers, just because they're more than a kilometer away from the powerhouse, doesn't mean that they now only want DC as opposed to everybody else who still wants AC output. That's why it should be configured with AC at the output. But these are philosophical things that I guess we will be continuing to discuss and iron out. Another question that I have for you, Nico, while I got you on the spot is, do you have a rough gauge for distribution cost per connection on the AC mini grids if you're looking at like within a kilometer from the powerhouse, and then maybe the costs if you're looking at beyond a kilometer from the powerhouse?
Yeah, like a kilometer of AC network could be anywhere between, say, $8,000 and $20,000, with an average probably around 14,000 or so.
Okay.
Depending, of course, on the national standards. Do you need steel poles? Can you install wooden poles? What is the voltage drop that is acceptable? And, then you design your system and the CAPEX results accordingly.
Gotcha. So that's like $140 per connection, roughly.
Well, yeah, there are different densities of population, of course. And then after all, you can connect more or less customers to this 1 kilometer line.
Yeah. So 140. So if I get that right, if that's like 10 meters of distance between households.
Mm-hmm. Which is very dense already.
Which would be very dense. Yeah.
And then for context on the mesh grid side, you're looking at about 30 meters average distance, and you're looking at about $40 to $60 on the distribution side. And I think we can get lower than that as well if we're using like aluminium conductors. Is that aligned with what you're looking at, Felix?
Well, if it's just the cost of distribution, yes. And I was surprised, Nico, you said like that you consider like, wooden poles cheaper than metal poles, because I think the opposite might be the case depending on the height of the poles. But if we would be forced to use CCA treated wooden poles, those are like 9-11 meter high Gumtree poles. They come at around $80 to $100 depending on which country you're operating in per pole. So that means that I'm still having the exact same cost in terms of distribution line. I'm saving slightly maybe on the cables because they can be a bit thinner than the AC mini grids. But I wouldn't say there is so much of a cost saving, especially on the poles, unless, and that is where I think the great benefits can come in, is I can break slightly with the regulation and say, okay, look, it's DC. Even in the worst case, if I have like 60 volt touching the pole and the pole is electric, since no one can get hurt from that, the safety regulations here could allow me maybe to use smaller, thinner, lower poles. And then, yes, I would agree with you that the cost for 30 meters or so could drop to like maybe $60 or so, yes.
Mm. When I talk about steel poles, I usually then consider the standard poles that are used in the countries, and those usually come at around $200 or so per piece. Cross-section of maybe 20 centimeters or 15 or so, like really heavy stuff that you bring into rural areas and install.
Okay. The steel poles I was referring to come off the factory for about $25 to $30. They're like 6 meter long galvanized steel poles or something like that. It's really just relatively thin kind of things because the slack and
more like a pipe that you put into the ground.
It's really a pipe. It's really.
Yeah.
Yes, exactly.
Okay, good. Now let's go into the business models. You already started talking about this. So both of you consider yourselves as the manufacturers of the technology. So you're not deploying and operating the technology yourself, if I understand correctly, but you're working with operators that then purchase the technology from you and operate the technology and integrate the technology with mobile money systems and these kind of things to then get their revenue. Is that correct?
Yeah, it's largely correct. For us in particular, especially on the software side, we provide mostly tools in terms of an Android app and a front end that mostly deals with the technology and analytics and operation of it, not so much on the collection of payments. So we are integrated with software as a service companies in the sector like Agaza, PayGops, Payg, Upia, and so on. Our philosophy, we don't want to necessarily bind the developers fully on our software. However, of course, there is a certain dependency by our developers to us because they purchase our mesh grid technology. But principally, yes, the explanation is correct. Like we're working on a B2B basis. We manufacture hardware. Our core business really is also making one-time money with selling that hardware, and then potentially there could be a service contract for maintenance as well. But it's largely focused on selling hardware to developers. And of course, for us, it becomes a business model only really if we're not only selling our mesh grid boxes, which of course are the core of a mesh grid, but also all the components that accompany the mesh grid, which are poles and cables and buckles and piercing connectors and whatnot to make a mesh grid happen. Yeah, but so from the developer side, I would say the business model is very much that of a, I would say, regular AC mini grid developer, ESCO company or DESCO company. So they are selling energy as a service to end customers that can be done on an upfront basis. There's different models of how you actually sell the kilowatt hours to the end customer, but ultimately you're selling energy on a regular basis to the end customer. And one major difference to the pay-go model is that if a customer doesn't pay, then they don't pay, but they're not really defaulting. While if I'm selling a solar home system and they're not selling for, let's say, 1 month or 2 months and they've exceeded their grace period, it's considered a default and the system needs to be picked up. That's not really the case for a mini grid because you'd rather dealing with the community as a whole. And therefore, even if you have a certain percentage of customers not regularly paying, it's about the average payment rate of the entire community, not so much of the individual, right? But ultimately, every mini-grid company has their own little nitty-gritty models in place.
Mm-hmm. The developers you're talking about that you're currently working with, are they coming from the solar home system sector mainly?
Our developers, not so much. Both of them have had previous experience with mini grids, and one of them also has had some sales in standalone systems. But honestly, they do a bit of everything. I have the feeling that those developers that really are reaching some degree of profitability in the off-grid sector, which is hard enough to achieve, really do everything as the demand comes, right? So there's a subsidy for mini grids, they do mini grids. If there is a tender for a solar home system, they do that, right? But without certain degree of subsidy, very few of those off-grid businesses are generally profitable.
I see. Is that the same on your end, Afi?
Yeah, I mean, there's a few kind of tweaks, but at the base of it, we are also a B2B technology supplier. And so I think maybe it's worth digging into some of the why and also giving a bit of kudos to the developers. They have a very, very, very tough job. They have to access the hardest to reach communities in the world under very challenging kind of political or security conditions, and then bring energy access to them and do it in a profitable way so that they can keep scaling. Just to give you an anecdote, one of our partners in Haiti right now, Alina Energy, doing a great job, have energized, I think, more than 15,000 people there now with mesh grids. And near one of the mesh grids, just yesterday, there was a news report that 70 people were murdered by gangs within 20 kilometers of a mesh grid. And so, yeah, developers are operating in hard to access areas. And the kind of mission that we have is to scale energy access globally and scale mesh grids globally. The local developers are going to do a much better job than we can. They know how to manage these operations. They know how to engage with the community and do it well. And so we're trying to play to our strengths. And what we're trying to do is provide the best technology possible. So not only on like the hardware side in terms of providing low cost energy availability and modularity, but also on the software side. Analogous to Felix, but maybe some of the things that we have specifically focused on. One is to make sure that all of the billing data can come through. There's insights available for the developers to see like where are unutilized assets, where can they boost more productive loads, which customers are generating sustainable revenues so that they can keep focusing on those areas to make sure that their portfolios are ultimately profitable so they can keep scaling. So yeah, I think the software part is also a pretty important aspect of making sure that operations can scale.
Mm-hmm. And after all, with mesh grid technology, these developers and operators now have a new, very cost-effective technology at hand that may help them become more profitable earlier. Mm-hmm. Let's talk about average revenue per user that you have seen in your systems. I guess they are very similar to what we know from AC systems, aren't they?
I keep the information high level because I don't want to give away data from any of our partners. But interestingly, with the mesh grids that have been deployed, we can see from 50 cents ARPU, which is definitely not going to be a viable project under any circumstances, not even going to cover the cost of operations, all the way to high teens, so like $16, $17 ARPU, which I think would be viable for even higher CAPEX solutions. So there's the entire range. And what's the lesson there? The lesson there is that site selection and community engagement and activation through productive use to make sure that the assets that you deploy there are actually utilized is incredibly important. And in terms of how we look at it, let's model for developers who are going to purchase the equipment in USD, but they should be accessing local currency debt financing. Otherwise, things are going to balloon out if the currency depreciates. Let's look at the average operations cost per year of about $15 to $20. And let's look at a realistic ARPU of $5 to $10. That doesn't change in local currency. Like, it's in local currency and it stays there from today's date. And then we found with our technology, which we're able to service this ARPU of $5 to $10 at, roughly $400 per connection delivered. This can actually lead to a sustainable 7-year payback period without subsidies. So that's no subsidies. And that's really what we're focused on, because we have to design this so that it can keep scaling after the subsidies are gone. And obviously right now we've got the $300 per connection mesh grid subsidy that's been announced in the DARES program in Nigeria. That's massive. And that's going to make all these projects even more viable and more attractive. And then when that subsidy is gone, I think we need to keep focused on making sure that we can keep hitting these ARPUs and keep the cost optimizing further so the market can scale.
Yeah, thank you, Afi. That indeed makes a lot of sense. The ARPUs are very similar to what you see in AC mini grids. It's the same type of customer after all, in a very similar community, just a different technology, basically providing very much comparable services. So therefore, expecting the same ARPUs is very reasonable. But if the mesh grid technology comes at a lower cost, then of course it's very attractive for mini grid companies in Africa to look into this technology and maybe pick this up, as already indicated. So now we said this technology is cheaper compared to AC mini grids, and we've already looked at the distribution network cost. So now what is an average cost per connection in a mesh grid?
For example, the DARES program has come out and they've said that the minimum consumption is 83 watt hours per consumer per day as the average load to be eligible for the milestone 2 of the subsidy. So the DARES program says 83 watt hours per consumer per day. We design our smallest systems to be about 3 times that capacity, because we know that the subsidy is not always going to be here, and you need to sell enough energy to generate enough revenue to have these projects be viable in the long term. So our smallest designs are coming around $350 to $400 with 30 meters of average distance between connections. And I think that is a very compelling cost point, because it's covered mostly by the subsidy. But at the end of the day, if the subsidy is not there, there's enough consumption there for it to continue generating that revenue. And of course, our systems, both Solarworx and OKRAs, are also modular, so that when you identify the pockets of productive use and increased demand, you can scale things up there over time as well. So yeah, I think we can get the cost down, but it comes at a cost to reduce the cost. So I would say let's keep it there.
Well, Afi, one question there: is the inverter included in that package?
Yeah, that's it. All included: inverters, batteries, distribution, screws as well, DDP, pass customs to the developer in Nigeria. Yeah.
All right. Where do you see bottlenecks for a rollout of mesh grids in Africa, in the markets you're in, and how could these be overcome?
Yeah. So I'm always trying to identify bottlenecks, and you have to do things thoroughly when there's a bottleneck and get it out of the way once and for all. So I think some of the obvious bottlenecks have been that mesh grids have had like a disadvantage from not being kind of known in the industry. But I think over the last couple of years, with a bunch of developers in Nigeria picking it up, including NG, taking a risk to understand what's going on with this technology, along with developers scaling in really challenging scenarios, like in Haiti, getting, more than 15,000 people connected where there's no power even for the telcos to provide coverage there, but people are getting access to 99% energy availability. I think we've managed to unblock one of the biggest bottlenecks, which is basically understanding from the industry at a high level, buy-in from some key stakeholders, such as the DARES program. And so now I'm looking at, okay, what are the next bottlenecks that are coming up? And 2 more bottlenecks. One that we're in the process of kind of navigating right now, which is when mini grids and mesh grids are rolled out, because they're under the energy as a service aspect, and because traditionally they're seen as infrastructure, as opposed to solar home systems, which is just like set it and then forget it. Well, for lack of a better term, it's just like set it and forget it and go to the next place, find the next customer, cherry pick whoever you can. Whereas mini grids and mesh grids are more a big community-based solution. So one of the bottlenecks that I had identified was, okay, well, with mini grids, there's a complex kind of commissioning and verification aspect of it that requires a bunch of the regulators to come and sign off on everything. And this is really adding so much time, as far as I understand, to the mini grid development process. Whereas when you look at the mesh grid technology, you're like, hey, it doesn't have high voltage, it doesn't have land acquisition, displacement of people. Like, do we need to go through this same process? So that's one of the things that I'm actually discussing with stakeholders, such as Rural Electrification Agency and NEMSA in Nigeria, to ensure we don't have that bottleneck. So when there are sites and they're suitable, we know it's low voltage, we know it's easy to deploy, just quickly get it done. So that's one of the things I'm actively working on right now. I'm pretty optimistic that we'll be able to have a lightweight process. And then another final bottleneck that I think the industry is going to face, and this is interesting, like if you look at SHS companies and like why so many people are into it, you can scale it quick. Like companies doing hundreds of thousands of systems a year, whereas the energy as a service or mini grid companies, they're doing thousands or tens of thousands, if at best, a year. So for us to scale this industry, how can we have the developers rolling out in the hundreds of thousands or ultimately millions a year? And I think it's going to come down to the developers really figuring out how to scale their distribution and their community engagement and their after sales support teams. And honestly, I think this is going to be tough, and the industry needs to figure out how to do that, because when we do, then we're going to see these infrastructure solutions rolled out at scale. So doing a bunch of stuff to try to help out there, but I'll stop there and pass it back to you guys.
Yeah, but Afi, I guess you would not be able to escape tariff regulation after all with mesh grids. But maybe we need a mesh grid specific approach to tariff regulation. Let's see. This would be subject for a next episode, maybe. New technology, new approaches.
Yeah, actually, I mean, to the tariffs, and we've been facing challenges there with particular for Uganda, right? So there's this tariff saying that mini grids, and under which mesh grids would also fall, is limited to 25 US dollar cents per kilowatt hour. And that is definitely insufficient to refund any mini grid or mesh grid. So again, then there comes in the need for subsidy. I would largely also echo the entry barriers and the challenges that Afi was mentioning. I also wanted to thank you, Afi, by the way, that, you've been driving this as a, promoter of mesh grids, especially in Nigeria, and bring this now into World Bank funded program of a significant scale. So that's been a job well done.
Thanks to the whole ecosystem. Thanks to Enensis as well. Yeah.
Indeed. Yeah. There was a lot of work.
It's a forward-looking ecosystem, I think. Yeah.
Well, there's one anecdote, though, I can say about Zambia, surprisingly, is that when we started our first mesh grid there, we thought, okay, look, so we play this just under the radar and sell it as a standalone system. And we actually then played it open book. We went to the Energy Regulation Board and the Ministry of Energy and informed them about it. And in fact, they said, yes, no problem. We've even regulated it. And the regulation says it's unregulated, basically. So in Zambia, there is a good blueprint of a regulation saying that if you have a grid that's on DC between 45 and 72 volts, the only thing you have to do, and also another limitation is that it has to be below, I think, 50 kilowatts or so, which is most mesh grids are below 50 kilowatts anyways. Then you just have to inform the Energy Regulation Board of the existence, and you can take whatever tariffs you want, though the Energy Regulation Board has the right to intervene in case they find tariffs are unreasonably high. And I think that's a very nice and lax regulation. You know that if you're overdoing it, they come and challenge you. But if not, if you're behaving, you can do what you want.
Okay. So you were already talking about Cameroon and Uganda and Nigeria and Zambia. What other markets and what other countries are most interesting to you?
Well, I think there is, it's unfortunate to say, but there's a growing refugee community, especially in sub-Saharan Africa. And I think, as bad as it sounds, but there is a certain customer base for us as manufacturers to serve refugee settlements because the density is very high, the consumption is quite low, so no one really put an AC mini grid in those communities. And also many of them are very scattered. If you look into the northwestern areas of Uganda, there's camps called BD, and it's not really a typical type of refugee settlement how you would know it, house after house, but it's clusters of refugee communities mingled with local communities. So they're really like villages, but small villages with high density. So they are predestined for mesh grids, if you ask me.
Afi, which countries are you looking at? What markets?
Yeah, well, I mean, ultimately, we need to look at every single market where there's off-grid people that need access to affordable energy. But right now, we have like a couple of criteria that we look at. So we need to have supportive regulatory framework, and we need to have developers who are our partners who can actually scale there and access those communities. So yeah, for example, in Nigeria, where we have NG as a partner and a very kind of forward-looking company with the multi-technology framework in mind, and also the REA and the DARES program, Nigeria makes a lot of sense. There's also the most off-grid developers globally in the world in Nigeria right now. So Nigeria makes a lot of sense, but as you know, we're also in Haiti. So whenever somebody's like, hey, I need the tech and I'm going to go make it happen in an area that other technology can't go, we're going to supply them. There's a bit of a battle internally because we want to be going to so many markets at once, but I also think there's a lot of good that comes out of focusing and doing it really, really well in one country and then letting that be the blueprint for a global expansion. Yeah.
Yeah. Are you setting up maintenance and service structures in each country you're going to?
Yeah. So that's one of the things that kind of slows us down, because our strategy is to ensure that every country that we're operational in, we set up in-country customer success, we set up in-country warehousing, we set up in-country after-sales support. And all that is an investment of time and resources, but it makes sure that mesh grids have a good kind of experience and reputation in the market. So, yeah.
Good. Felix, anything to add from your side? How are you handling this?
No. I think that's, I think covered it most.
Same thing. Now, a quick feedback from your side. How many systems have you installed already? And how many customers have you connected, each of you?
Nice. So with mesh grids, we have about 40,000 people energized so far, which is pretty exciting stuff. And half of that basically is happening in Haiti, where it's really exciting to see these hardest to reach communities get energized. And I think it's the tip of the iceberg. Things are ramping up a lot more now.
Yeah, for us, I think, as we are a blended company between standalone systems and mesh grids, we are significantly smaller than OKRA on the mesh grid connection side. So all in all, we are serving about, say, 600-700 individuals as it stands right now. But we are having about 30,000 standalone systems that are equipped with our technology or are fully our technology. That's 120,000 people directly affected by Solarworx standalone system technology.
Mm-hmm.
Nice.
Okay. Good. So now what is up next for mesh grid technology? What are you currently developing?
Firstly, no secrets. Like Felix and I, we share about tech specs and how we see the industry evolving. And I think we just need to give a shout out to you, Nico, and also the industry, like the REAs, the World Banks, like the developers. Like it's a very collaborative space, and we need to be collaborative in order to solve this really challenging problem. Yeah, so that doting on the industry aside, we're working on a couple of things. So let's start with the software side. With DARES, we're expecting a massive ramp up of mesh grids in Nigeria. And we're finding like some of the bottlenecks actually being like internal operations, basically getting all of the sites simulated and having a bill of materials for all the sites. It might sound a bit boring, but we're building an internal product called the Network Planner 3000. And basically it takes all the geo coordinates and allows tweaking to optimize the cost to the demand and spit out a site-by-site bill of materials. Very useful for the developers. Another software, we have so much data that's coming from the field that we have more than 100 dashboards showing everything from, energy consumption by user type, uptime in community versus non-payment rate, looking at potential demand for productive appliances. But having more than 100 dashboards is not really that practical for any of our partners. So we're currently investigating some AI-enabled smart solutions that can basically feed the right insights to the right stakeholders so that they can actually action that data to keep their portfolios operating effectively. And I might just quickly drop one update on the hardware side, but we had some challenges with communications because the grid basically the telco towers were not getting enough energy from their diesel so that they weren't providing connectivity to our smart devices in the field. So because we have a bunch of data that's coming through, we've actually upgraded from being all 2G based communication on every device to now being YSUN based communication. And YSUN basically allows high data throughput, but it's unlicensed, so we don't have to pay that fee. And then it hops that data to a point where there is 2G connection, and we send it out from there. So it's really reducing the cost of getting the data out and sending remote firmware updates and controlling these systems. An exciting under the hood update. Yeah.
Yeah, I think from our side, we also consistently develop the software in particular further. We are quite intensely working on our Android app because we also do have a front end for Windows and all those kind of things. But we believe that especially when you're a developer in the field, you would like to have that flexibility and ease of accessing your data directly from an Android app. So currently we're consolidating most of the stuff that we have initially programmed in our Grafana front end and move that over into the Android app. That's one of the things. We're also constantly improving the hardware further. So we're currently developing stuff like line breakers so that we can isolate folds on the line so that not the entire network goes down if someone shorts the grid or something like that. And there's also other little add-ons to the grid. So we have LoRa-controlled street lighting that sits on every pole of the mesh grid. So LoRa, just to say what about LoRa, that's like an industry standard that allows low bandwidth, low data communication, usually between IoT devices to share stuff like, token data, consumption data, technical data, maybe even firmware updates. We actually run firmware updates via LoRa. So those things we are constantly improving, but those little switches that control the street lights, we do already have them in the field, testing them currently in Cameroon. We also want to have a device that allows direct consumption from the power line as opposed to having a converter in between, because there's certain productive use appliances. If I'm looking at, for instance, Axols, it's another company, they're doing great productive use equipment, like a milling machine, for instance, that could be directly fed from the power line. There's no need to step down the voltage for those stronger DC brushless motors. So those kind of things are currently in the pipeline or development.
Interesting. Yeah, thanks a lot, Felix. Thanks a lot, Afi. This was highly interesting. I really liked discussing this innovative new technology with you, and I believe it has a great future also among our listeners who are mainly AC mini grid operators. So thanks a lot to both of you. Before we close, please tell our audience quickly how they can reach you if they're interested to learn more about your technology.
In our case, just check on our website, solarworx.io, or just send an email to info@solarworx.io and feel free to reach out to us. I'm going to send you some further details and manuals and explanation about our mesh grids and standalone systems.
Similar. So okrasolar.com, OKRA solar. And then you can just email me directly at afnan@okrasolar.com. I'm always keen to talk to anybody who's interested in doing energy access better.
All right. Thanks a lot. I have the feeling that we will talk more often in the future because this is such an interesting subject that should get more space on media in our sector. Bye-bye.
Cheers, guys. Bye-bye.
Thanks a lot.
This episode of the Mini Grid Business has been brought to you by Innovators, your one-stop shop for sustainable mini grids. For more information on how to make mini grids work, visit our website, innovators.com, or contact us through the links in the show notes. The Mini Grid Business, powered by Innovators.